All right, hello. We're here with Madhu Venugopal from Red Hat. Madhu's working on the NetVert effort as part of the OpenDaylight project, and has been also developing a lot on OpenStack. So we're going to talk with Madhu today about OpenDaylight, OpenStack, and the sort of commercial grade open source efforts in SDN controllers. So thanks for taking the time today.
Sure, Nick. It's a pleasure.
Yeah. So I know you've done quite a bit of work on OpenDaylight and OpenStack, and one of the reasons I actually wanted to talk with you for the class in particular is your experience in the open source community in developing SDN tools. And can you just kind of describe a little bit, your history with OpenDaylight and just more generally, like the OpenDaylight project has really picked up steam over the last year. What's kind of driving all of that?
Yeah, OpenDaylight I've been involved from the beginning. So I was with Cisco for like a long time back. I was there at Cisco for a long time, for a decade, and then we started experimenting on the controller business after watching the OpenDaylight Foundation 2011. That's the first ONF, and got inspired by all the great bigs, right? Martin Casado, and, Scott Schenker, and others. That was an inspirational point where we started working on the controller, and that evolved to be one of the code base for OpenDaylight, right? So I've been working on from day one, and as you said, the project has grown leaps and bounds for the past 1 year, 1.5 years now. When we originally pushed the code to the first commits that we did on OpenDaylight project, it was around 60,000, 70,000 lines. Now it is like 1 point some. We can't even track. It's like millions of lines now. It's like close to 2 million lines of code. Maybe it's crazy, right? Yeah, I mean that is my current experience with OpenDaylight. It's still not. It's still in nascent state. It's a 1 year with 2 million lines of code. But as you said, it is ramping up. It's catching up a lot of attention, and it is quickly becoming the de facto SDN controller out there.
Yeah, it's seriously picking up steam. It also seems to have a sort of a serious backing from industry, Cisco, IBM, and so forth. And but there's clearly a big open source element to it too. So can you kind of describe, like, is it fully open source? Is it mostly open source? And then I imagine like these vendors are going to want to add their proprietary bits in as well. How does the whole ecosystem play out? How open is OpenDaylight, I guess, is another sort of way of asking it.
Right. So one thing I've realized, at least personally, right, when I started OpenDaylight like few months back, in fact, it's been more than a year now. I was new to open source at the time, so even I had this vision of open source where hey, you open source the code, but keep something proprietary within you, and then try to have an edge over others, right? I think all the vendors have realized that it's not a way to go anymore, because the differentiation is definitely not in keeping things proprietary to you. Differentiation, because when you look at SDN and openness, they go hand in hand, really, right? I mean, it's a serendipity where the open source for networking came up really at the same time when SDN also picked up steam. So from what I'm seeing today, at least in OpenDaylight, there are a lot of vendors participating, of course, but it's open to the term, because Linux Foundation is backing all this, and Linux Foundation is known for its openness, and even though engineers are coming from various vendors backing, but we are all engineers working for a common cause for advancing the SDN to the masses, really. So it can be as open as it can get. So.
On those lines too, I'll definitely sort of jump in and ask you a little bit more about what it does and how it differs from other controllers. But I mean, while we're on the topic of openness, I had a couple of questions. Like, one is, what's kind of the best way for people to ramp up and learn about it? I mean, one of the things, I guess you're you're tied in with the SDN Hub guys as well, and they've done a really nice job packaging a VM for people to play with OpenDaylight. But I would say it's still like it's got a famously steep learning curve. I think down the road, like I'd certainly wonder if students should be looking at it and things like that. But it's got a pretty steep learning curve. Are there efforts afoot to kind of make it easier to pick up? And I guess along those lines, how do you suggest people get started? Like, are there good tutorials and things like that out there, or what's the best way to kind of jump in?
I'm glad you touched upon this topic of the steep learning curve. And yes, ODL today suffers from that problem where now it has its learning curve, and the community is working hard to make it easily consumable. And if you go to this OpenDaylight mailers, you will see that this is one of the topmost thing about how to make it consumable for everybody, not just for the core OpenDaylight developers, but for everybody out there. How to make it as simple as like now, just pick it up and start using it, right? And folks from SDN Hub are doing some wonderful job in addressing that particular concern, where pick OpenDaylight and they kind of have a different distribution for using OpenDaylight, which makes it very simple for folks to pick up and start using it. But using it is different from developing on it. So the core developers on OpenDaylight, we are all working together to make it simpler for anybody to develop apps on top, right? That is going to be the difference between usage and not using it on the SDN controllers. And OpenDaylight today, I mean, as you know, we have first release out, second release coming along. There are lots and lots of features being contributed, and slowly we started realizing that even though we can develop code on OpenDaylight, others are not finding it easy at all, right? And the community is speaking up now. It's very good, where they are giving a lot of good inputs, great inputs, and we are actually changing the way we operate in OpenDaylight, not just be the wild west and write code and throw it out there. Rather, we are actually making really concerted effort to make it simpler for others to consume.
Yeah, that seems super important, I think, going forward. I guess one of the things that I've seen in some of the tutorials you've given and demonstrations online, and certainly it seems like one of the nice features of OpenDaylight is its ability to support a lot of different plugins via this service abstraction layer, or I guess SAL. I don't know if that's how you call it.
Right.
But it seems like then OpenDaylight can potentially support a lot of different Southbound APIs beyond just OpenFlow. So I guess a couple questions there. What's the current status of OpenDaylight support for different versions of OpenFlow? And then what are kind of other popular Southbound APIs that people are using? I mean, I assume there's more to the story than just OpenFlow.
Absolutely. So when OpenFlow, yes, OpenDaylight supports, as you said, SAL is the layer which is going to provide that abstraction between the southbound protocols to the northbound applications, right? That's the abstraction layer, and that provides the unifying effect on an SDN controller like OpenDaylight, where you can support various ways to talk to the devices. It could be from a management plane, like OVSDB is one example, where it is mostly a management plane protocol where we can talk to OVS switches and manage it effectively. OpenFlow is certainly the linchpin of SDN. Whether somebody likes it or not, when vendors might like to say, hey, it's imperative, we don't like to use it. It doesn't matter. OpenFlow is the linchpin, and it's out there to it will succeed. I mean, it is succeeding already with various on various standards as well. And today OpenDaylight supports OpenFlow 1.0 to 1.3. We have 1.3 plugin that supports these protocols right there. And there are efforts already started to work on 1.4, 1.5. As ONF make progress on the OpenFlow standards, OpenDaylight will catch up and try to implement them the fastest way possible, actually. And one good thing about sorry, go ahead.
I was going to say like one of the things that you mentioned was sort of the support for these different OpenFlow versions, if you will, and I noticed that Floodlight, for example, has this thing called Loxygen, where they create these bindings for different versions of the protocol. I guess the theory is that as the wire protocol evolves, you can sort of create new bindings relatively easy. Do you see some value in something like that, or is the strategy just like you're going to write plugins as the protocol evolves and just hope that you can kind of keep up with what's going on?
So OpenDaylight has something very similar to that, where OpenDaylight is we have a lot of Yang modeling there, right? So we use Yang as the model language for on the model event side. So similar to Loxygen maintains its definition using a separate way, and then we automate it and then plug it into the controller. Similarly, in OpenDaylight, we have this Yang model, where we define the wire protocol is kind of defined in the Yang models, and as the new version comes along, we'll update the Yang model, and once the Yang model is updated, the code is auto-generated. We have this Yang tools project which runs through these Yang files and auto-generate the source code, and the source code gets attached to the controller, and things starts working, right? And this Yang, the way we are looking at Yang is as a bigger vision. If you look at it, there are other protocols also makes of Yang. So even though OpenFlow is the wire protocol that we talk between controller and the devices, since the Yang itself helps as a buffer mechanism where we don't have to keep writing these wire protocols by hand, rather define them using Yang and then try to put them into the controller and try to make things work. So it is kind of similar to what is being thought about in Loxygen. But one practical issue that we are facing is Yang is pretty awesome, where we can do things using models. Model is a very way to abstract things. But when it comes to augmentations and extensibility and so on and so forth, we are facing some challenges today. Hopefully we'll make it simpler as well. So once we make it, again, all of the everything boils down to make it simpler for end users. Even though it's complicated now, the moment you make it simple, simplicity wins end of the day, right? So
absolutely,
once you make it simple, then it'll be adapted much more wider.
Absolutely. I guess I got a couple other nitty-gritty questions, and I wanted to ask you like some more far-out kind of vision types of things. I guess one of the things I think, and actually a lot of these sort of reflect, I think, some disconnect between what's going on in research and what industry folks are talking about, and I guess some of the nitty-gritty questions here. I was just trying to bridge that gap a little bit. One of the things that I keep hearing about in industry forums is OVSDB, and that's something I guess certainly. You don't read about it very much in research papers. Like we don't talk, we certainly aren't using it in assignments and things like that. But how does OVSDB kind of relate to the OpenFlow protocol? Do switches need to support OpenFlow to also run OVSDB? And what's the relationship between the two and the on-the-wire control protocol? And what's kind of the best way to think about, good uses for OVSDB?
Yeah, so OVSDB is like close to my heart as well, because that's one of the reasons why I, in fact, quit Cisco and then later joined RedHat, right? Because I wanted to work more deeper into OVS and OVSDB as a mechanism to manage OVS, and we know that OVS as an open vSwitch, right? It's becoming kind of the de facto standard on the edge switching platforms, where even OpenStack uses OVS as the edge switch. So on OVSDB helps manage this switch, right? So we can simply see OpenFlow as a control plane mechanism where we can program flows and make the hard. Look at the traditional way networking. We program things on the TCAM and the MAC tables, and traffic will hit that and start forwarding things, right? While it's the customer's requirement to go and configure the management plane is different, where we used to configure VLANs and configure tunnels and so on and so forth. That get translated into hardware programming, and then flows come and hit that and start getting forwarded on the hardware. We can consider OVSDB and OpenFlow as purely complementary protocols, where OVSDB takes care of all the management level stuffs for OVS or OVS software where it's running on, while OpenFlow takes care of the control plane for the forwarding layer, right? The Open vSwitch as a switch, being open and open sourced, it has both this protocol exposed, and OpenDaylight being this multi-protocol controller, it's the perfect marriage between these two, Open vSwitch and OVSDB, where we use OVSDB as a mechanism to actually do the tunnel orchestration. So when it comes to network virtualization, I'm sure we're not talking about network yet, but network is if you ask me, the application of SDN. And of course, there are other views that network is not SDN, but to me, network is the application of SDN, where it really proves a point there where how automation can really help on the data center and the cloud. If you look at OVS being the edge where we can actually orchestrate the VXLAN tunnels and GRE tunnels, making the underlay as a pipe essentially. For that, OVSDB actually helps set up these bridges, set up these tunnel orchestration. All this is done using OVSDB, while OpenFlow is used to actually program these flow programming rules on the OVS edges. Also do the multi-tenancy, right? We can say, hey, traffic coming on this VNI, match it on a VNI and forward to a given specific internal virtual port. So all the OpenFlow takes care of the flow programming, while OVSDB takes care of the tunnel orchestration. And these two hand in hand is able to deliver. We are able to deliver network virtualization just by using these two protocols.
I see. So like one way to look at it too is you can't have things like virtual servers or NFV or sort of middle boxes sitting on virtual machines and things without something like OVSDB as well. Or maybe you can, but like it makes the management of those kind of things easier.
Absolutely, yes. I mean, you actually hit right on the head here, right? So OVS expose both the protocols. Either use OVSDB and OpenFlow or just OpenFlow. Let's take Mininet as an example, right? Mininet is a wrapper over OVS, and today Mininet actually opens up only the OpenFlow channel for the switches, but not necessarily the OVSDB channel, right? While we can also open the OVSDB channel and start managing things from the controller. And there are cases which I know already where the OVSDB protocol itself has been not specifically for OVS only. There are vendor switches which they implement the OVSDB protocol, so we can do the VXLAN to VLAN translation. The VXLAN gateways are implemented on top of X switches on various vendor switches today, where they don't support OpenFlow, but they support OVSDB, right? So they go really complementary to each other, and you can pick and choose which protocol you want to use. And OpenDaylight can control all these protocols in isolation or in tandem together. And Network is an excellent example where we use both the protocols to actually manage the network virtualization.
Yeah, that's interesting. I guess that leads me to some more higher level questions, I think, which is one is, I guess, like it seems like I mean, a defining characteristic of OpenDaylight is sort of the ability to have these plugins that manage all kinds of things, not just OpenFlow switches. I mean, you can, as you point out, you can manage tunnels, overlays, servers, other things. I mean, I guess, I mean, there's a low-level question there, which is like, what are the useful plugins in OpenDaylight people should be familiar with? But I think the bigger question is, what do you think this all means for SDN? I mean, it seems to me like SDN started off being kind of synonymous with OpenFlow, but now it's clearly not just going beyond OpenFlow, but also this is way more than just configuring a network of switches, right? You've got other things as well. So can you talk about what do you think this means for just, I mean, are we talking like you can't really have SDN without without compute and storage as well, or can you say a little bit more about where you think this is going and what the Open Daylight philosophy is?
Definitely, yeah. The Open Daylight as a project, right? We try to cater to wide variety of SDN needs. Like so, Open Daylight on the first hydrogen release, we had this 3 distribution called the base edition, enterprise, the service provider edition, and virtualization edition, where each one tried to cater to different kind of use case and customer requirements, and that's where you start seeing the actual difference between how OpenDaylight can help enhance the SDN, whether it's OpenFlow or other protocols. It will help define it. So let's take piece by piece here, right? If you look at the cloud or data center, folks are ready to experiment, right? It's like greenfield. Many greenfield operations are there. So and overlay is one thing which is accepted on a data center with virtualization space, and hence virtualization edition today you'll see that we talk about OpenStack integration, we talk about overlays, we talk about OVSDB, we talk about OpenFlow, how to manage these channels and everything. While if you look at service provider edition, service providers are all a bit more traditional than the enterprise cloud, the cloud data center, where it is not rip and replace of our existing infrastructure. Rather, it's gradual progress into the new world of SDN, right? Where what they do is they want to keep the existing infrastructure and talk if the controller or a central management plane can help move from an existing infrastructure, increase their operational efficiency by automating many of the things that they're doing manually today, they're happy with that. And if we go and tell them, hey, you know what, replace your core box and replace with OpenFlow switch, they're never going to do that, right? So and hence they really love the concept of OpenDaylight supporting this netconf protocol, where we support netconf with the Yang model, where their existing device supports netconf and Yang, right? And OpenDaylight supports SNMP as well, so they can rather make use of SNMP as well, and so on and so forth, right? So so it is the OpenDaylight's vision of supporting the existing brownfield operations, also transitioning the new cloud into the new world of virtualization. So all works in tandem, right? And not to forget NFV. Right? NFV is a big play there, right? And with so much options available on OpenDaylight, right? NFV can really NFV can really make use of it. Where it's not new. I'm not going to say a new thing saying, hey, NFV and SDN are 2 different things. Of course, they are 2 different things, right? NFV is function virtualization, and SDN is the software-defined networking, of course, right? But they are totally complementary in nature. Where we already hear folks talk about using OpenStack as a way to manage their NFV devices, right? We already hear that. We already hear things about service chaining. We already things here about now. Orchestration is not going to be a thing of data center only, right? Orchestration is a generic requirement across all the distribution, all the use cases, all the massively scaled use cases, right? So we are going to keep hearing about using OpenFlow, OVSDB, and other protocols in tandem for various use cases. But today we have a crystal clear view of, okay, for data center cloud, we have this OpenStack requirement with OVSDB and OpenFlow. Service provider has a different requirement, but those requirements will just all go flat out, and there'll be a space where a lot of plugins are available for folks to use, and it's really up to the folks to make use of it on the orchestration layer, right? And we're already seeing things happening there on the service provider network. For NFV, they want to use OVSDB, OpenFlow, and also netconf on the side. So it's like it's all out there.
Mm-hmm. Yeah, there's definitely a lot of stuff out there. I think that leads me to another question too, which is, I mean, it definitely seems like, I mean, one of the things that sort of strikes me when I look at the OpenDaylight architectures is a plugin for all kinds of things, but and you can sort of mix and match. But I think another thing that at least like some researchers are thinking about too is like, I mean, you mentioned, for example, like OpenStack and NFV on one hand, and OpenFlow switches on the other. But it seems like now you've kind of got separate protocol, separate plugins, separate sort of ways you do this and then you do that. But some people are talking about, let's just view the whole network as an abstraction, and I don't have to worry about, oh, is the southbound, is it OVSDB or OpenFlow or netconf or something else? Let's just talk about a sort of network-wide abstraction. Do you think such a thing is realistic? Like, is that something OpenDaylight folks are thinking about, or is that? Yeah, what are your thoughts there?
Right. Certainly, right. Let me take a step back and then we'll come back to this point, right? So if you look at network virtualization, it's about that, right? It's about treating network as a resource, and the moment you say, you know what, hey, I have a compute, I have the compute running here, I want to have an elastic way to expand my compute, and then without needing to worry about network is on the way, right? That's not going to be the case. Where I don't want to think about network as a place where I need to spend time on, where network is supposed to be up and running all the time, 100%. There's no downtime for network. It should not be the case, right? And if you want to achieve that, you should not be worried about the nitty-gritty protocols, nitty-gritty details about whether I'm using OpenFlow or OVSDB or netconf. If the moment you talk about these protocols, that means we already are getting into the complex nature of networking, right? So I am totally on board to the topic of, hey, I don't want to talk about protocols at all, but someone has to do the job, right? Someone has to carry the dirty laundry, right?
Someone has to do the plumbing, right? Yeah.
Yeah. And the someone is the person like me and Brent Salisbury and Dave Tucker and others who are actually working on the ground, right, making this thing on the open source, right? So one thing I really want to convey, at least on this topic, is that even though we spoke about SDN, we spoke about the various protocols, we spoke about OpenDaylight, but whichever way SDN goes in the future, I would be pushing so hard on being the openness that we have today, right? So SDN is synonymous to openness, whether it's open source and open networking. Whichever way it goes towards, it has to be in open, right? If it goes back into the proprietary nature, I would say it's not SDN. The moment you say proprietary, we should not call it SDN. Let's call it out right there. So that's my interest on that. So what I'm coming at is, once it's open, once it's all open, once it is available out there, like Linux, right? Linux is open, it's available out there. Not everybody who's writing applications on Linux is worried about Linux stability. They all take for granted Linux is working, right? But there's a huge Linux community which maintains it, right? So let's think about OpenDaylight as that one where, yes, we will talk about protocols, we will fight on protocols, we will find the abstraction, we will do all this one. But as an application developer, don't worry about what we talk about the nitty-gritty protocols. You worry about your logic. Don't worry about protocol. Assume that things will work fine. And if you are a networking geek like us, come and contribute to this insanity, right? And that's how it's going to be, right?
Absolutely, yeah. So I guess I liked your analogy with Linux in particular. I mean, obviously most of us don't have to worry about the internals of what the latest kernel patches and developments are and things like that. I guess by analogy with OpenDaylight, like you said, maybe most of us wouldn't have to worry about the guts of the Southbound API and maybe things below the SAL. I guess is that maybe the layer below which maybe we wouldn't have to think. But I guess maybe question to kind of leave you with might be, okay, you have the plumbers, and then you have maybe the application developers, and then you have the researchers, maybe. So for the application developers, what do you think are what applications that you like to see developed on OpenDaylight that would really take advantage of the unique capabilities of OpenDaylight? And then I guess from the research side, what do you think are the hard research questions, or things that just pure engineering aren't going to solve that you're hitting your head against now, either in the plumbing or above?
Oh, I mean, these are all some very interesting, close to my heart questions as well. So we know, it's proven already that network virtualization is the the king of applications today, and SDN for SDN. And if you look at other kind of applications, they are actually a handful. Right? You don't see a wide deployment of all other applications, but SDN is really potential is like enormous. The SDN potential is enormous that now we can actually see the network, the one that you talk about, network abstraction, right? Not necessarily the overlay-based network virtualization, but network abstraction as such can be achieved using SDN completely, yes, right? Not just on data centers, not just on the service provider, across everywhere, from campus network to enterprise network to security, firewalling, and whatnot, right? So whatever we see today as a networking feature on these closed proprietary boxes, we can see everything today with the available merchant silicon and the boxes available there. We should be able to achieve anything that given box differentiates using SDN, right? Mm-hmm. So it could be any application, right? From from DNS thing to from portal to whatever, right? And SDN Hub, I would say, who has not seen SDN Hub, I would recommend them to go and take a peek, a look at that, where folks like us, right, who want to write SDN applications, not necessarily married to OpenDaylight or RedHat or anything. They are actually doing this kind of researchy application-like projects where they are exploring things there. And I would recommend everybody to come and contribute there, where they are kind of the application wing, where they are trying to write applications on top of these controllers, and they are trying to solve some real world applications as well. So,
what do you think of what do you think of the hard technical problems that you're just really banging your head against, and maybe might be good for researchers to think about?
Oh yeah, I mean certainly. There are two things that I really don't know how to address that, right? I mean, we are working towards various solutions on that. But so if you look at it, right, when SDN was originally it came about, the reactive nature of SDN got a lot of attention, where we said packets will go to the controller manages the packet, and then after that things will get programmed for forwards things, right? Yes, that might work for a small research kind of thing where we can start doing things, but really in real world folks never want to do anything like that, really, right? They don't want to see the line rate traffic hitting the control plane and getting programmed and things like that, right? That is something which is like frowned upon, and on the real world, right? I mean, there could be some application which might be doing that, but by and large, folks try to do things proactively, where proactively program the rules and things starts forwarding, right? So this reactive nature of thing, right? It is stellar, where we can do a lot more innovative, interesting things in the reactive nature, which we can never do in proactive, right? So this solving this problem of getting the reactive innovation, right, into the programmatic world of doing things at a scale and performance is something which I don't think we have solved the problem yet, right?
Still struggling with that. Okay, yeah.
That is one thing which is very, very interesting, where if we can solve that, right, then I can think about like tens and hundreds of applications which can be used in production at scale, at performance, right? That is one thing which we are all struggling with, actually, right? That's what I forgot the second question that you asked. Sorry.
Oh, the second question. Oh, I guess you had said that there were two problems that you were kind of struggling with. Like one was sort of the reactive nature of a lot of control applications. You said maybe there was like another challenge. I don't know.
Oh yeah. The other challenge is the controller, right? Controller being the central point of I don't want to call failure, because I never want the controller to fail, but it's a central point of control, right? So being a central point of control, there are a lot of research topic today that, hey, it's logically centralized, but they're actually distributed using clustering, right? But even there's one kind of a problem which is still out there. Folks are still yet to get the grips of it. Where if you look at today's network without SDN, without centralized controller, it is completely available, right? Network is available where it is partition tolerant. The CAP theorem, right? It's a well-known CAP theorem where consistency, availability, and partition tolerance, right? Where the existing traditional network is available and partition tolerant while not completely consistent, where protocol can get synchronized the way it wants to, but eventually it'll be consistent, right? While if you look at the controller, on the controller side, we are saying that we have to make it so simple for applications to make use of, right? If you want the application controller to be simple to make use of, and we're talking about a clustered controller where states should be synchronized, and if you say, hey, it will be eventually consistent, then application cannot trust the controller's consistent nature of data, right?
Yeah.
All right. Then we say that, okay, I'll make it consistent way of handling things. The moment you say consistent, that means the partition tolerance is poor, right? And it's not highly available, right? So how are you going to solve the problem? How are you going to make it simple for application to make use of by providing the transactional guarantees, providing the state guarantees, the consistency guarantees, at the same time, make sure we are partition tolerant and available and everything, right? That is something which it is like, I don't know how, that's one thing which is a good research topic, which these two are something which we don't have an answer yet completely. There's a lot of research paper on that. Folks are saying, hey, I want to do, if you look at Google as an example, right? They came with Bigtable and then came the entire big data cloud where eventual consistency is the king. Then same Google came in 2002 and said they are using Spanner, which is a highly consistent database, right? Which is like it's not fully latency sensitive, but it's good enough for their applications, right? Now, which one will it take, right? I mean, so that's one thing which is a very valid discussion on both sides, right? Whoever says eventual consistency is the right way to go about, they have a valid point, and those who say consistent mechanism is important for applications to make use of, but hey, are sacrificing the partition tolerance, right? So these two are the important topics which I think it's going to play out there.
It's very interesting. Yeah, lots of challenges ahead. I guess I mean, well, I'll leave with one final question. I mean, like, given in light of all these challenges, things you want to have happen, do you have any recommendations? People in the course or others who want to get involved in OpenDaylight. How do they sort of join the crusade, if you will?
Yeah. So I give it already, right? OpenDaylight has a steep learning curve. It has a learning curve, but I would say it's a time worth invested because we are seeing so much interest in that, and folks like SDN Hub, right? They are making it life simpler for folks to get started, right? So yeah. I would say participate in the community. The open source projects are meant for participation, right? Folks must come in, participate. Once they participate, they will take the we'll see the charm of open source, OpenDaylight. The initial ramp up might be hard, but there are folks who are really willing to help, right? So Ben Salisbury, I want to call him out here, right here, because he is one person who kind of motivated person like me, who kind of, when we started looking at open source, we saw a person who is spending so much time writing blogs, doing the midnight oil and posting things for others to make use of, to benefit out of it, right? So in that line, a lot of guys out today who are spending time, to betterment of others, where they can come and participate, and we are there sitting in the IRC channel 24 hours. We don't have life at all. We sit there, help folks who wants to participate, and I would say IRC channel is a blessing where folks, we are all there. OpenDaylight, IRC channel. I'm personally in OpenDaylight OVSDB channels. So come talk to us, participate, and there are a lot of good tutorials out there. And the wiki page is a huge treasure trove. And OpenDaylight has a ask.opendaylight.org where folks can ask questions. It's like they get upvoted and so on and so forth. It's like Stack Overflow. So there are a lot of tools being experimented today, but the key thing is if you sit on the sidelines and expect things to come, it will not come, right? So come participate. Once you participate, you can really see the benefit of OpenDaylight.
Awesome. Yeah. So get involved. Great.
Get involved.
Okay. Thanks, Madhu. Thanks for your time. Really appreciate it.
Sure, Nick. Thanks a lot.